Okay, I think we'll get started. Good afternoon again. My name is Bob Ballantyne. I am the lead architect in the mid-range storage business unit for Dell. Mid-range is quite a big organization. We produce the various storage boxes that go into all the telecoms, Microsoft, most of the big providers of Kubernetes and the cloud, etc. What I'm going to be talking about, actually, before I tell you, any ideas what the topic, the software factory is? Anyone? So the concept is based on, let's say, Henry Ford, his idea of the factory and doing things efficiently and making things go faster, which is really what DevOps is all about. And I've been doing this for a few years. As you can see, originally I'm from Glasgow, Scotland. If you can't understand me, I apologize. I don't have any subtitles, so you have to go with it. Mid-range, as you can see here, is quite a large organization. We have about 1,000 plus developers working on our products itself. And then we've got 200 to 300 DevOps and testers. So the organization that my boss heads up is about 240, 250. Which is all of the test organization and all of the DevOps organization. So my responsibilities are across all of that. I worked for Dell for the last 2 years, and that's because Dell took over the previous company, EMC. So I've actually been with this company for 14 years or so. And the rest of it, it's not really that important. Other than to say I'm probably older than most of you. So this is what we're focusing on. How many of you recognize these sort of things? The problems that you have at scale. Every day is a game of whack-a-mole or firefighting. We're always running about trying to figure out how to fix this problem or that problem. Because of that, I sort of stood back and said, well, why do we have all these problems? What's going wrong? What could we do to overcome this? Because in the end, all of these problems are costing us money. Either through productivity or just the fact that somebody's got to go off and do something. It doesn't matter. It comes down to the bottom line. It's costing the company money. So back to basics. And this is actually something that I've had to do just recently. Because of the makeup in the company changed, what I've had to do is talk to the developers. So back to basics means looking at best practices, governance, and of course visibility. You can see the bullets there around what these actually encompass. I'm not going to go into that too much. But the best practices are something that is very important. You need those. That's your basis for communication within the company. And this is what I've had to go back to the developers to get that foundation that we can communicate about. Once we have that communication going, now we can talk about the governance model and the visibility. And it really forms this triangle. If you don't have the visibility, you can't check whether or not people are doing things correctly, recognize the mistakes. If you don't have the governance, then you can't sort of call people out and say, look, you screwed up because you didn't follow the best practices. So you've got to do a better job next time. If they had followed the best practices, okay, stuff still happens. But at that point, it's now a shared responsibility, so we can come together, fix the best practices so that we don't make those mistakes again. We're all in that same boat when we're following the best practices. It's when someone's outside of the best practices, they make mistakes, and that's when the fires start. The whole point of establishing the best practices is so that we have this common stuff, as I said, and to set up the governance. And it's funny because, as I said, the developers that I'm dealing with just now, they went off in lots of different directions. They've all got their own little best practices written, but there's no commonality between all of the different organizations. So from a DevOps perspective, it makes our life impossible. So that's why I say it's really the foundation of the communications that we're talking about. Back to basics again. The next thing is looking at the tools which we actually support. I imagine that most of you have got a similar sort of stack to this. I originally put this together just as a sort of visual aid or a tool in itself, and it's laid out in these 4 layers on purpose. At the bottom, you've got your sources of truth. You want to be careful and keep those absolute. That's where things come from. You don't want to be replicating those unnecessarily. You don't want to be creating multiple sources of truth for the same thing, because that's just going to lead you into problems. And so, as we move up, I'll come back down to that one. There's a couple of other diagrams down the bottom, which is where the data is generated from, and we'll get into that in a little bit. But the main sources of truth that we have is GitHub, LDAP, so that we can find everyone in the company, and Jira, which is where we do our planning. That's where things are coming from. On the next layer, we've got our basic tools, which do the jobs that we're being asked to do. I say basic because this is the build and test infrastructure. This is the orchestration. This is Jenkins. It is Coverity or some of the parts of SonarQube. It is Bullseye or Jacoco or something like that, where we're gathering information to control the process. Excuse me, control the process for developers. This is the area where developers are actually taking their code and promoting it along the line. On top of that, we take the information from that for data persistence so that we can get history and all the rest of it. And if you think about this morning's keynote, what I've just described falls quite squarely into what was talked about with SDM. The SDM product that was talked about this morning is taking the sources of truth, taking all the data from that middle layer, storing it in a repository, and then giving you some sort of presentation at the top layer. So it's really encompassing all of that to give you the insights that you need. Going back to the previous slide, that's the visibility aspect that we need to provide the governance to make sure that we're doing things as fast as we can, going in the right direction. So it's a different way of looking at the same things. And you can see in our tool stack, we've got Jenkins, we've got Gradle, Maven, PC. We use SonarQube. We've got our own internal build database. We use MySQL and Postgres to sort of store everything. We've got Nagios for monitoring. Over in the far left, there's still some undecided areas there between Kibana, Grafana, Elasticsearch. That's because we're still building this up. I say that because as I said, this is part of experience that I've gained. It's also partly the roadmap for our DevOps part of the BU. That's how we want to be moving forward. So that's the basics. That's what we're dealing with. But who's the customer? The customer is the most important thing that we've got to be thinking about. Well, here we have them, the developer. Developer gets hired, they're given a desk, etc., somewhere to work, and they're told, okay, you're going to be developing code on this project. You get your code from Git, you'll get the task stories, etc., from Jira, and this is what you're going to be doing all day. That's the life of a product developer, and we should all recognize that. But there's a little bit more, because once the developer has written their code or modified their code, we want them to deliver it. And one of the things that I've said is all the deliveries have got to be done using pull requests. This was actually a change for some of our developers. They would think that they were doing the right thing, and they would generate pull requests. But then they had this thing after it called a merge build. And I'm going, a merge build? That doesn't make any sense. The whole reason for a pull request is to encapsulate all the build and test and make sure the code you're delivering is good before you put it into the branch. So why are you doing a build after it's gone into the branch? Why can't you just reuse the other stuff that's there? Oh, well, we might be merging other stuff together with it. So the integration and the build, the merge build and all the rest of it, you've got instabilities in the integration branch. Yeah, that happens occasionally. But that's just wrong. You want it stable. You want to have this guarantee that anyone goes to your integration branch, they can just pull out the code and use it. They could pull out the code, build it, and it's guaranteed to build. What you're doing violates that guarantee. Stop doing it. That took a while to sort of get across to people. And there's still quite a few developers I work with won't hear it. But the pull request is one of the basic building blocks. This is something that I learned at a conference a while ago. The light came on, it's like a contract. It says, my code is good enough quality to go into integration, passes all the checks, on it goes. If it doesn't pass it, it's not going in. Simple as that. It's like going to the supermarket. You expect the produce to be of a certain quality. If it's not that quality, then it shouldn't be on the shelves. Same thing in your integration branch. If it's not that quality, it shouldn't be there. Coupled with the pull request, you've got some feedback loops. You've got the immediate one when the builds break, what I've just been talking about. You've got some other ones where the delivery goes into Git, goes into the other branch, but then you've got other testing, etc., which is done after that, and that creates defects, and it gets fed back into the system and gets to the developer. So this picture now shows you everything that the customer is actually dealing with. This is what we're trying to work with. And the blue arrow down the middle is our production line. That's what we're trying to move as fast as possible. So the software factory is trying to move that production line, that blue arrow, as fast as possible. That's what we're working with. To do that isn't as easy as just what I've talked about, because developers love to get in there and do their own thing. My term for it is boutique build and test. Oh, sorry, wrong way. So what happens is the developers bring everything together, They write their scripts to get stuff from the build resources, the test resources, run tests, and then they say, here you are, I'm done. And you go, I can't, how do I integrate this into Jenkins? Give me a Jenkins file. I don't know how to do that. Or something similar. That you're lucky if they understand Jenkins file where I'm working at the moment. I've seen examples of the execute shell, 1,000 lines of bash script. I keep telling them all of that should be in Git. I've seen Jenkins files, 1,500 lines long, and I go, no, I can't get it into shared libraries. So this is where we've got to educate the developer. And to cut back in the education, one of the things I realized is that all of this is coming from the workspace. And when you think in some of the other talks that you probably attended at this conference, you see that Jenkins X talks about its workspaces and getting stuff from there, setting it up. It's using containers. We mount the workspace to volumes in the containers. This was another light bulb moment for me, because when you think of it in those terms, you see, okay, the workspace can actually be composed of different directories, one for configuration, one for source, one for test resources, etc., etc. I can mount those onto my container. The container just has Maven or GCC, or maybe it has both. But that gives me an abstraction so that the developers can do their thing in their sort of boutique build and test, and I can take that and run it here. And then this fits on top of that production line I was talking about earlier. Still following? So the next thing, and this slide actually was one that I was talking to James Strachan about last year. I didn't know the term GitOps at that time. GitOps, as I found out, was the same thing that I was talking about, just James and I were sort of using different terms. So I've modified the slide from then, and now it talks about GitOps. GitOps itself is really, I was calling it a quality ladder. And we all have this in our organizations. It's the process of the developer delivers it to build and test, or to his pull request. After the pull request, we put it into the integration branch. We then usually run regression tests or the like after that, because regression tests take quite a while. It ends up that we've got several different branches or stages that we go through. GitOps is the practice of tracking what we're doing in Git. It's using Git to track a process, that's all. So as the developer moves the code into the bottom layer, that's his pull request, that's the initial build and test. We then go into regression testing, and it goes up to the next layer. Well, if it fails regression testing, why should it go into the next layer? So again, we use a pull request around that, and that means that we can guarantee the quality again. And there's system functional test and all the rest of it, and it moves up. And what I've been telling everyone is, we want to be using the same processes. Common processes make it easier for DevOps. So let's get all of this into pull requests. Let's automate what's happening between the pull requests, and that's what GitOps demonstrations have been showing you today. And now we have common processes. Everything is being recorded in Git, so we've got traceability. And we get the reproducibility thrown in because it's all, again, it's in Git. So we're using this common tool. It doesn't have to be Git. We actually use GitHub Enterprise. But any of basically your SCM, GitLab works almost the same as Git, as GitHub and all the rest of it. So when I say Git or GitHub, I'm using it in a generic sense. It doesn't have to be that specific flavor, but they're all very similar. You build up this quality ladder, and you're really just using it to track your process, the process that's already there. Talking to our value stream people, they're going, what's a branch ladder? What's GitOps? It's just the stuff we're doing today. Why do we need to add something? We're not. That's the type of discussions that I end up getting into. It's sort of trying to show people all we're doing is using the tools that we're currently using, standardizing our processes, making it easier for us in the long run. So that's the basics of that's the basics of what we want the developers to do, how we want to get everything in the factory moving from start to end. Common processes, traceability, reproducibility. Because the last two are very important, because that's how we track down things that are going wrong, differences. The last piece I want to talk about on the sort of general infrastructure is the piece that is very important to DevOps. This is the piece that provides the visibility to management, to the value stream, to DevOps themselves. This is what allows us to see what's going wrong. It's all the feedback loops. What we're doing is using the Kafka enterprise service bus. This morning's discussion was talking about, yes, I've forgotten the acronym now, the new Jenkins product. It's going to be doing something similar, where it's capturing all this data and feeding it so that you get the visibility. We've connected up basically a fire hose to GitHub, so that every event generated by GitHub goes onto the Kafka topic. We can search all that data now. It goes into the database. We can produce graphs. All of our defects information is going in there, and we're continually adding to it. One of the nice things about this, and it's giving satisfaction to the DevOps developers, is we asked them to add a piece of functionality for developers. Excuse me. When they add that functionality, they've got to also add the metrics and get it all the way through into Kafka and be able to store graphs. That gives the DevOps developers more appreciation, because now they can start to see what they've created, how it's responding, whether or not it's steady state. They get to understand the informational value that the value stream is looking at, or the managers are looking at, or whomever. And so it's actually been quite useful. So that's the basic infrastructure. We need to be able to scale this, because we have multiple programs. How many of you work in one product? Anyone lucky enough? No. We work on quite a few. I've just put a sample in here. How many of you think of DevOps as a product? It's one of your products that's just as important as the other products. And this is one of the reasons why you've got to get management on board to support your DevOps initiatives, because it is a product. You've got to be investing in it. You've got to be delivering value from it. It's just that the customer is different. The customer is the developers, as I said earlier. It's not what's shipped out externally, which most of the managers, etc., are thinking about. So remember, DevOps is one of these products. And then to get that to scale across the products, What we're trying to do is combine it, the GitHub concepts that I've talked about earlier, GitOps, etc. Jenkins, which is driving that conveyor belt from the developer slide, that blue arrow. Jenkins is really the motor that's driving that conveyor belt. It's just going non-stop, doing the builds and tests and all the rest of it. It's like the motors on a factory conveyor belt. Taking that with Kubernetes, you then have your ephemeral environment, and this is where we're going, because as we heard from talks this morning, and I've been talking about it for quite some time myself, we need the elasticity and the scaling of Kubernetes to be able to do build and test. Build and test is very spiky. The loads are spiky. Developers come in the morning, the load goes up, they work through the day. If we have static slaves, things get queued, and then they go home at night and things go quiet. Before I started giving this vision to where I work, we were up at 50 Jenkins masters and about 400 Jenkins slaves. We had it all worked out to be able to roll them out easily to new teams. Everything was working great, all the teams were happy, and it worked for 1 or 2 releases. But then the build and tests changed because the product changed slightly. It was these different boutique build and tests. Things started to fall apart. Where are the Jenkins resources? Nobody knows. There's 400 of them out there. They're lost. So we went to Jenkins Control Center. And now we're in the process of getting all those Jenkins masters into Control Center, just so that we can solve that problem of where are all the Jenkins resources. So when you're at this sort of scale, you need that sort of tooling. You need to be able to track all the resources you're using, whether it's the masters and or the slaves. If you're using Kubernetes, you don't need to worry about the slaves. So it's that combination. Then, if you go back to the tool stack, you saw up at the top, we had this visibility layer. And like any factory, you need a control room where you've got all the dials and all the gadgets. This is where you actually see what's going wrong. You see your trends. I mentioned it before. We get our developers now to produce these nice graphs. We've got Kafka pumping the data into Postgres, which, by the way, is the same as the SDM. I was talking to the Jenkins SDM lead outside, and he's saying that they're using Kafka and Postgres as well, which is really good because now I've signed up to be one of the beta testers. So we get all this data, and now we can provide just the important information. I don't want to be in the business of providing everything that DevOps can show, or everything that SDM can show. Or one of the POCs we did recently was Gradle Enterprise, and it's got a whole bunch of lovely graphics, and it goes on and on and on. So each of the vendors usually provide a rich set of graphics, but it's all specific to their stuff. So what I've proposed is, let's reuse their graphics, but we build just the important KPIs, visibility into the important stuff, so that we can produce these dashboards to show us the important information, and if something's going wrong, we start to drill down. And that gives the visibility to the managers for what's going wrong in Jenkins or whatever else. Why is this pull request taking too long? And now we're getting more. It's a supervisory control room in a factory. And lastly, when you put it all together, you really have something that this is DevOps. This is the factory that we're producing. It all comes together. You can be moving your resources, whether it's your teams or your Kubernetes resources or test resources, simulators, etc., between different product lines. You can be on the horizontal, you've your quality ladders or your GitOps, and things are moving automatically from your left to right. We're making use of Kubernetes, Jenkins, Docker to enable this abstraction so that we allow our developers to still be creative. They can still do their little boutique build and test, keeping it the way they like it, but we're just saying, okay, when you do anything, it's got to be done within a Docker container. So it's got to be able to be run by our pipelines. This is much easier to go after than what we're looking at on that very first slide, where we were playing whack-a-mole. Because when you look at it from the whack-a-mole perspective, it's like, what's going on? So, that's the software factory. Thank you. Any questions? Yes? So did everyone hear the question? What happens when a failure occurs in the quality ladder at one of the middle stages? What happens today? This is just describing what you do today. It's not something new other than a slight modification of the way you're thinking today. But it is actually the same as what you're doing today. What's been added is the fact that you're encompassing everything in pull requests and using GitHub or Git to trace the transitions as you pass it from one team to another team. Today you have those test failures. How do you handle them? Okay, when they start creating bottlenecks because you're getting too many, your quality's shot. Why is it getting that high? If it's caused by the same thing happening over and over again, you probably captured it, and now you're getting the metrics to be able to recognize some sort of pattern. But it is basically based on what you're doing today. Yes? Exactly.
So that product would die on the bronze range, would never reach gold. That's how I'm seeing it. Is that
exactly? What actually happens is we create a Jira defect, and then that goes back to the developer, and we'll sort of capture enough from that environment, save it so that the developer can come back and look at it. But it never gets promoted to the next level. Yeah, you've now got to have a hot fix coming in to sort out the problem, or you've got to start backing out that change. But that's what we do today. That's how developers work. Yes? Yes. At the moment, it's for example. There is an initiative where I'm working to standardize terminology and all the rest of it, so I'm actually pushing for something more generic like this, because what we see today is people name branches in all sorts of obscure ways, and the naming conventions get complex, and it causes friction. You see the friction more when people, instead of referring to the bronze branch and the content in the bronze branch, they'll talk about the content that came out of testing to get into the bronze branch. I pull my hair out at that, because it's not about testing itself, it's what branch it's in. That's easier to understand. Branch, it's that quality. Yep. One of the things I forgot to mention, this picture is really more of a fractal type design. Because at the very bottom, you have lots of developer branches coming together. As you go up, we've got one product displayed here, but you can have multiple products. But it all looks the same now because you're using the same processes, everything's wrapped within the pull request. And that also makes it easier for developers or testers or whomever to understand what's going on because it's common process. Yes? So, the questions were, what defines the quality bar for going up to the next level? And then, how frequently does this occur? Right? I can't answer either of them. That's the truth, because it depends on what it is you're building. The frequencies and the quality for your customers is different from my customers. We have 60 million lines of code that we're bringing together in multiple repos, and it's a daunting task at the bottom. Building all of that and qualifying it just for the developer can take up to 8 hours. Going all the way up that stack can take 2 weeks to get the level of quality and reliability that would be suitable for going out to an external customer. But that's our products. That's a storage product. That's what you're tying up to the Xfinities and the like. That's what we sell them. So we've got all of that. The frequency which it goes up, at the moment it's manual, but I'm trying to get it automated. It really depends on how fast the developers are delivering in and how frequently or how long the testing takes. Because like the grocery shop analogy, when the fruit and vegetables come into the grocery shop, you don't check all of them one by one. You go through the packing sheet to make sure you've got all the correct quality stamps there. And if it has, okay, off the pallets, and then it goes. You take it home, you haven't asked for all of those quality stamps. Instead, you've accepted that it has that quality, you expect that quality, you take it home and you put it into your cupboards or whatever. It's the same thing. How frequently do you go to the shops? Well, it's as frequently as you need to go. It depends on your processes, is the real answer. Yes?
Can you elaborate on what information you've been collecting using your Kafka backbone and what sort of insights?
We collect, as I said, we've got a fire hose connected to GitHub. So every event from GitHub is going into that. That's for every developer's commit, checkout, you name it. That's part of the, so one of the things that we added was ticket checking. We have, developers have got to put in a specific reference when they're doing their commits, and we can tie that to the work product, the original Jira story. So we've got that correlation. And then it becomes a lot of ETL and Postgres and the like. Right, and the same thing, it all then starts to fit into what Jenkins is talking about with our SDM. So, yeah, we discussed several of those types of options, and some people didn't like that one, other people liked a different one. Now we're getting into the problems on the bigger enterprise where you've got all these different opinions, and that's another issue. But that goes back to the best practices at the beginning. Yes?
So on your feedback slide, you had a Kafka topic. What was the topic referring to?
This one. So the Kafka topics, we've got lots of different Kafka topics. When we've made this a democracy, anyone can generate data and put it onto a Kafka topic, and the topic gets automatically created. We want to open this up to developers to encourage them to be recording their own metrics on performance or whatever, and being able to display it so that they've got the history. They can then help us build up this ecosystem.
So potentially you could do it on a developer by developer basis?
Yeah. It's not got that far. If we start to see problems on the scaling of it, we may cut back, but at the moment, it's still open, where that's the way we expect to go.
So is there someone responsible for pulling the topic information and summarizing it in some way?
That goes back to what I was saying. When we have a DevOps developer inputting new work, actually it's a two-part answer. Take the first part before we get to the developer. My boss wanted certain KPIs. So we went out and we actually pulled those. We had someone build the graphs and all the rest of it. And that got him happy. He went away and now we could get on with our stuff. Today, when developers are generating new functionality, whether it's monitoring something, we've got this 256 terabyte share that we keep almost topped up, and we've got to monitor it. The developers that were writing the algorithms on the retention policies for that, we got them to feed all the changes into a Kafka topic. We then said to them, okay, you're pushing the data into Kafka. Now we want to see it in the database. And that's a small microservice that is easily modified. You've got it in the database. Now I want to see a Grafana chart. And that's what I meant when I said that gives the developers an extra sense of satisfaction, because we work with them getting the data into the Grafana chart so that it's information. It's not just raw data. It's how we want to see the information. And in this case, there was the total amount. They had to do 30-day averages so that it would smooth it out. And then there was the day by day, which is basically noise. But getting them to go that far, they sort of start to see, oh, okay, now I understand it. And it makes it useful. So that's how we get it done. Anyone else? I can talk about this all day. DevOps is my hobby, so. Anyway, any other questions I'm about for the rest of the day? I'm not flying out till tomorrow. Hope you enjoyed it. Got some takeaways. Thank you.